Saxon's Trig, lesson 45, page 319, is supposed to be two parts: conditional permutations and two variable analysis using a graphing calculator. And because not everyone has a graphing calculator, I tend to skip section B and not do it at all. If, however, you have a graphing calculator and you would like to learn how to program yours, you can try following what the book gives you. But I'm going to focus on part A here, conditional permutations. Now, we already know that we have originally learned how to fill in lines with the numbers. Then we learned a shortcut formula for permutation. Now in this, because of the way they're going to be changing it, I can't use the shortcut. I'm going back to filling in the given information. You'll see what I mean here. Example 1. How many odd counting numbers can be formed from a 3, a 4, and a 5? So I was given 3 numbers, 3, 4, and 5. So I only have 3 spots that I can be filling into for this particular example. Now, I skipped over a wording, how many odd counting numbers. So for it to be odd, this last spot is affected. So out of my numbers, could I put a 4 here and have this overall number be odd? No. So my only choices for this number to be odd are the 3 or the 5. 2 choices there at the end. Okay, how many odd counting numbers can be formed from the digits 3, 4, and 5? No repetition is permitted. So now, whichever one of those I used, I no longer have. That leaves me 2 other choices. Can the middle number be whatever? Like, is there a restriction just because it's odd? No. So it could be either of those remaining 2 numbers. Now I've used 2, I can't repeat. So there's only 1 number left for the first spot. And it doesn't matter, it'll be an odd number whether it's 300 something, 400 something, or 500 something. So now that I've filled those in, I know that I'm supposed to multiply those together. 2 times 2 is 4, times 1 is still 4. So there are 4 possible ways to organize that. Example 2, find the number of odd 3-digit counting numbers. Okay, here we go again. That are less than 600. So I have to be less than 600 degrees. And I'm just organizing that by jotting it down. This is not proprietary to how you have to solve the problem. So it's got to be odd. What numbers can be odd? Let's just jot them. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, because obviously 10 is no longer a single digit. If I use 0, it's not odd. 1 is odd, 2 is not, 3 is odd, 4 is not, 5 is odd, 6 is not, 7 is odd, 8 is not, 9 is odd. So 1, 2, 3, 4, 5 possibilities for my last spot. Does it say anything about repeating? No. So I assume I'm allowed to repeat unless it says I can't. All right, so for the middle number, is there any limitation to any of the numbers? Because I can reuse even the odd that I just chose. Not for the middle. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 choices here for this one. But the beginning one, I do have a limit because I have to have a number that is less than 600. So could I have 600 something and be less than 600? No, so I cannot use the 6 as the front number. 700 something is going to be bigger. So all of those are thrown out. But 599 is still less than 600. So I can use 1, 2, 3, 4, 5. Can I use the 0 for a starting number? No, because then it's a 2-digit number, not a 3-digit number. So I can only use 1, 2, 3, 4, or 5, which is those 5 choices. And then how do we put those together? We multiply and we get the answer 250. Example 3. 5 math books and 4 English books. 5 math, 4 English. Again, I'm just trying to organize. are on a shelf. How many permutations are possible if the math books have to stay together and the English books have to stay together? Okay, so I know I'm going to have a slot of 5 for the math books, and I'm going to have a slot of 4 for the English books. So how many math do I have to choose from? 5, then only 4, 3, 2, 1. For English, 4, 3, 2, 1. And I know I'm going to multiply all of that together. You can do 5 factorial times 4 factorial, same thing, on your calculator, or multiply all of that out. It shouldn't, I'm just going to look at the book and see what they got. 2,880 for this amount. Now here's where life gets a little tricky. If you are not thinking carefully, you might box that as your answer. However, I chose to put the math books first, then the English books. The only distinction that the problem said was the math books have to stay together and the English books have to stay together. So if I flip-flop and I put the English books first and then move the math books to second, it's the same set of numbers. So that's another 2,880 possible choices. So I could just double the 2,880 or multiply by 2, however you wish to do it. But the actual answer is 5,760 permutations. Example 4. How many different 4-digit odds, 4 blanks, must be odd, can be formed if no repetition of digits is permitted? All right, it's got to be odd. So back here, we already found out that we had 5 possible numbers that would make it odd. Repetition not permitted. Okay, now I could continue to work backwards, but I'm going to jump to my first number because I'm not allowed to repeat. So whatever odd I just used, I'm throwing out. But that leaves me 1, 2, 3, 4, 5, 6, 7, 8 other numbers, not the 0, because if I do, it's not a 4-digit number anymore. And that's why I wanted to jump to this first one, because I'm not allowed to repeat. 4, 5, 6, 7. So there were 8 possibilities here. Now I've thrown out 2 numbers, but the 0 has come back into play for whichever one of these I want to do first. So that's 1, 2, 3, 4, 5, 6, 7, 8 possible numbers again. Now I've used 3, so I only have 7 possible numbers for here. And then we multiply all of those together and we get 2,240. Example 5, last one of these. An elf, oh, this one. An elf, a gnome, a fairy, a pixie, and a leprechaun are to sit in a line. So 1, 2, 3, 4, 5. 5 dots. There we go. How many different ways can they sit if the elf and the gnome, insist on sitting next to each other? Okay, so if I put the elf in the first place, then the gnome is going to be in the second place. So if the elf had to be first, that meant the gnome had to be second. That leaves me 3 choices for the next spot, then only 2, and 1 for the final. Okay, so I'm going to multiply 3 times 2 times 1 and get 6. But that was assuming elf came first. If elf is second, then gnome is here. Then I get my 3, 2, and 1, again 6. If elf is here, gnome is here. 3, 2, 1, again on the 6. Elf is here, gnome is here. Same thing, we get another 6. So 6 times 4 is the 24. But I made an assumption that the elf came first in every one of those. It didn't say elf had to be first. Gnome could be first. So if you flip-flop these and you put gnome first, then elf, you have the same 24 again, so you're doubling that to a total of 48 different ways. And then, as I said at the beginning, your part B is about learning how to use a graphing calculator if you want to try to program that.